Thanks very much, Nisaka. Thank you for that. And thank you to everyone for joining us this morning. Apologies that I will probably keep saying this morning because it is morning in Manchester, England at present. But I'm conscious it is a different time elsewhere in the world. So thank you for joining us, whatever time it is. As Nisaka said, this is a feedback session for Pearson's International Lower Secondary Curriculum, or iLS curriculum. My name is Andy Dalton Bunker, and I am the principal examiner for the iLS qualification. Excuse me. I'm also a little bit croaky this morning, so you may need to excuse me as I croak my way through this, hopefully not coughing and spluttering too much. Just a quick overview of our session for this morning. We are a little bit late starting just to allow people to join us, so we may run on a little bit, but we're anticipating the session will last around 45 minutes, and then we'll have 10 to 15 minutes at the end for any questions that you may have. As Nisaka said, if you do have any urgent questions during the meeting, there is the chat facility, but otherwise we'll save questions for the end of the meeting, either in the chat function or you can unmute and ask questions towards the end. The intended outcomes of the sessions are that we'll do a brief overview of the paper, where it's come from, what the intentions are, what it does for us, an overview of the marking, how that works at this end, and then delve a little bit deeper into the principal examiner feedback, the report that I write each year in conjunction with other examiners, and then look in more detail at the papers from last summer and last autumn, so the 2023 series in both summer and autumn, the June paper and the October paper, what went well, which questions were attempted well and tackled well by the candidates, which questions went less well, which ones were more challenging and candidates performed less well on, and then any potential improvements, some hints and tips on areas of the paper, or particularly the way that candidates tackle the paper that may help to improve their attainment and achievement moving forwards. And then, as I said, there will be a question and answer session towards the end. So first step is the overview of the papers. As I said, these are looking at the June 2023 and October 2023 papers. So we will be looking at both papers. Both series are absolutely identical. We ensure that when we write the papers, there is an equal question coverage, equivalent styles of question, styles of paper, and equally challenging papers as well. So it's not that one series is designed for one cohort or another. The numbers are slightly larger in the summer series, and initially the October series was designed as a resit window, but it has now become open to all entrants. So we do have increasing numbers in the autumn as well. Both papers, as you can see, and all of our papers are calculator papers, and that will be a feature of this morning's session and something we'll talk about moving forward. The equipment content list for both papers is exactly the same, and again, we'll cover that in a bit more detail later on, and the instructions that candidates are given are exactly the same. So they should receive exactly the same experience, whether they sit the papers in June or in October. This specification has been in place since 2018, first exam in 2019, but the iLS curriculum examination has been in place since back in 2012. For any of you that are familiar with the English education system, we used to have Key Stage 3 SATs in Year 9. This paper was an international version of those. And in the same way, the Key Stage 3 SATs were designed to prepare candidates and students for their GCSE exams. These papers were very much designed with the IGCSE in mind at 16. So hopefully preparation for those. And we do work in conjunction with other teams of examiners to ensure that there is some consistency between those papers. The paper, as you can see, is 1 hour and 20 minutes long. It has 2 sections. Section A is a 15-question multiple choice section that covers grades S1 to S3. So a range of questions, but not the very most difficult ones. And there are 4 answers for each multiple choice question, or 4 possible answers, candidates having to pick one of those 4 on each occasion. And then section B is a range of short open questions, various ranging from 1, 2, 3, and 4 mark questions, different styles, different topics, and covering the whole grade range from S1 up to S4. That's worth 65 marks in total. So a complete total, overall total of 80 marks altogether. Both papers, excuse me, both papers are written by myself and a team of people over the course of around 18 months to 2 years. We spend an awful lot of time working with subject specialists to ensure that the mathematical content is correct and accurate, to ensure that any kind of cultural or contextual references are relevant and up to date. They are very much written for the international market, so you will see a range of different contexts, a range of different names and things like that, so different parts of the world. Any currency questions, we tend to use US dollars, as that's the most prevalent currency across the world, but We do accept that some candidates in their countries will use currencies that don't have 2 decimal places. So we're very welcoming of candidates who give answers to 1 or 3 decimal places with currency, again, taking in different international protocols. And equally, I know there are slightly different styles and formats of using things like decimal points, in that many areas of the world, the decimal point looks like a full stop, just a dot, whereas in other areas it's a comma, and we're very accommodating of that as well. The papers are written intentionally to be as simple and plain English as possible. They are hopefully not too wordy, and we are very conscious of the words that we use and the language that we use. We do have language specialists looking at our paper, reviewing our paper for us, not from a mathematical point of view, but from a grammatical point of view, to keep it as easy as possible. But part of the change we made in 2018 when the new spec was launched was that there are more problem-solving questions, which obviously do involve more words. And that was intentional to prepare the students better for the iGCSE course. So there are some more words involved. Many of the students I know have English as an additional language, and that's one of the challenges that we'll discuss a little bit further later on. So moving on from the papers, obviously the crucial time period once the students have sat the papers is the marking. We have a very similar team of markers and examiners, including myself, a series of team leaders and examiners who work online to mark the papers that are submitted, both in June and in October. That team is virtually the same for both theories, slightly bigger team in the summer, slightly smaller in the autumn. I've been incredibly lucky to work with a very, very experienced team of examiners since we started this qualification back in 2012 in many instances. And all of the team are very experienced examiners in several other areas as well. So many of them will assess iGCSE, GCSE in England, have done Key Stage 2 and Key Stage 3 exams in this country, also work on things like functional skills and A-level qualifications as well. So it's an incredibly experienced, very knowledgeable and very accurate team of markers that we work with. I'm very lucky to work with them. We do, even with their experience in knowledge and excellence, we do continue to monitor their work very, very closely. One of the beauties of marking online is that I can, and the team leaders can, monitor the marking that all the examiners do, and we do that with very closely. There are a number of items which we insert into our marking sets. So as well, alongside your candidates' responses, there will be some predetermined answers where I and the other senior markers have determined what mark a question should have been awarded, and we monitor the examiners are giving the correct mark for that case. The accuracy figures are incredibly high, almost always 100%. And the examiners do assess students very, very well. On the very, very odd occasion that we have had issues with individual examiners, we then have the opportunity to pull back all of their marking that they've done and review it. And the team leaders do an incredible job of reviewing their team's progress through marking. And if there are any issues, which, as I said, are incredibly rare, they will pick up on those very quickly and go back and remark items if necessary. So we've had very, very few inquiries about results after examination results are released. And when we have, the marks have always been upheld because there's no change and the marking is incredibly accurate. So it's something we're very proud of. The mark scheme you can see the cover of is published on the website, and all the resources that I'll talk about today, the paper, the mark schemes and the examiner reports, are all available on the Pearson website. So there's no specific additional materials available during this session, but all the materials that I talk about and refer to are readily available on the Pearson website. So you go onto the Pearson website, go into mathematics, go into international lower secondary, and all the documents are there for you to access as you please. Within the marking guidance, we have a consistent first page. I'm not going to read through this. As I said, it is available publicly. But our general marking guidance underpins everything that we do. As I said, I have a very experienced team of examiners. We have over the years brought on some new examiners, and this is their start point of their training, so they understand exactly what we're aiming to do. But it does mean that candidates are marked very consistently across the board, whether they're the first paper through or the last paper through. There are some candidates whose papers, for various reasons, have to be marked physically on paper rather than online, but they receive exactly the same treatment as well. Our mark schemes are all very clear. We'll see them later. Applied positively, so that all candidates will be rewarded for what they have done, rather than having marks knocked off for what they perhaps haven't done. The examiners refer to the mark schemes throughout their marking. They're always present with them when they are marking. And there is no ceiling on achievement. We can and regularly do award full marks to candidates who get every question correct. It is a challenging paper, particularly for students who are sitting at 13 and 14 years old. But we do every year have a good range of marks across the entire mark range. And many of the students over the years have achieved full marks. So all the marks are available, and we're more than happy to see that. The examiners are categorized into 3 sections. We have the more junior examiners who mark the most straightforward questions where the answer is just one number and it's a tick or a cross essentially. But within that, we give them every possible opportunity. So students who write their numerical answer in words, perhaps, or in a different area of the paper or anything like that will still receive credit. We then have our graduate markers who are mathematicians, who are experts in their field, but are not necessarily at the forefront of their profession in terms of examining, but they are experts in their own little field, in this case mathematics obviously, and they will mark the most straightforward questions where there is a bit of variability in answer, perhaps 1 or 2 marks to award, but again very straightforward marking. And then we have our expert marking team who are doing the most difficult questions, so the problem solving questions, the questions that require explanation or written answers or perhaps drawing answers that are a little bit more challenging to assess, and they're reserved for our most experienced examiners. Many of the examiners are capable and experienced in doing both graduate and expert marking and move between the two. But they're the principles that we use for all of our mark schemes. You'll see that on the first page or 2 of all of our mark schemes, and that's how we begin our marking. Within the multiple choice section of the paper, obviously the marking is a little bit different in that the students will put in a cross to indicate their choice of answer. If they change their mind, they're instructed to cross out their answer and recross another one. These are generally marked by a computer essentially, so that it will read their answers, but there is the opportunity for us to see them and see how they've answered and when they've answered them. The papers are very simple and straightforward in terms of the layout. There's usually just about enough room to show a bit of working out if you need to. We obviously don't assess that at this point. It's just the answer that's important, but I will refer to some working out later on that may be important for you. And many of the questions are designed to examine common misconceptions. So the example I've got in front of us here, I think it's question 12 from the summer paper last year, is given the radius of a circle, work out the circumference. And obviously there's some obvious confusion that can lie within this question. So confusion between the radius and diameter, confusion between the formulae for circumference and the formulae for area. So the question answers, or the possible answers that appear on the screen, are not just random numbers that appear from nowhere. They are very much assessing those misconceptions. So as you can see here, the correct answer is B. So the circumference is pi times diameter, in this case the diameter being 8, so double the radius. We do 8 times the diameter, we get 25.1 to 1 decimal place, and that's the correct answer. If candidate doesn't get that, they get one of the others. It should allow you as teachers delivering this, perhaps using these as past papers and preparing students in the future for other series, it should allow you to unpick what their misconception is, rather than just going, oh, you've got it wrong. You can unpick their misconception, and our mark schemes have evolved over time so that rather than just saying B is the correct answer, it then says this is what A would have led from. So in this case, instead of doing pi times diameter, they've done pi times radius. On part C, instead of doing pi times diameter, they've done pi times radius squared. They've essentially found the area. And then on the last one, they've done an area calculation, but instead of doing pi times radius squared, they've done pi times diameter squared. So it should allow you, depending on which wrong answer they get, to unpick potentially which misconception it's there. Obviously, when you're looking at that and when we're assessing that, it's difficult to work out whether it's just a bad guess or a good guess, but in the vast majority of cases, it does allow us to delve in a little bit deeper. And you will see over the next couple of years that our mark schemes that are coming out over the next couple of years will have even more detail in them. So there are going to be some short sentences on the mark schemes for the multiple choice questions to explain where incorrect answers may have come from. So hopefully that will be more useful for you in the centres. Moving on to section B, and I've gone straight to the last question just as an example. Our section B mark schemes are laid out for you to be able to use just like our examiners do. Question number on the left, a working column, as is often the case, shown here as an example. It's not the only way that we'll allow or permit students to work. There are many ways in maths of solving the same problem in different ways. This is one example of how to secure full marks, but that's not the only example we would accept. The expert examiners are very well trained to acknowledge and award marks for other methods of getting the correct answer. The correct answer is in the middle column, and there are occasions where there is more than one correct answer. It may be a range of values, or it may be an answer that can be expressed in different terms, perhaps in third form in terms of pi and things like that. And then down the right-hand column, we have the number of marks available. Probably the most important one from your point of view, if you are assessing these as past papers and mock exams, is the additional guidance, and that shows how and where we award the marks. So M marks are method marks, whether the calculations are correct or not. The method, if you'd have done that method, had it got you to the correct answer, would get them the method mark. It's the working out that's important there. And then the A marks are accuracy marks. So they're the values that they've found. So in this case, it's the value of the length and then the final answer of 48. You will also see in some sections that are B marks. B marks are independent marks, so they're independent of anything else that's going on, and that's often just a one-off answer or perhaps units with the answer at the end of it. So, and you will see on this one as well, it's got in brackets there DEP, and DEP on M1 means that it's dependent on previous M1. So in this case, a candidate could earn M1, the first method mark, and then an A1 mark. They can only then get the third M1 mark if they've got the first one. So they don't need to have got the first A1 mark, but they do need to have got the first M mark. So hopefully that should help you to use the mark schemes within your centres and award marks in the same way that we would do it in the final exams. Moving on to the principal examiner feedback. I write the report each year in conjunction with a number of my senior colleagues. The content and tone and format of that report is very consistent. So you know what you're going to get each year. If you look at one of them and read through it, you will find the messages change over time in terms of what the candidates are doing. It's very obvious that many of our centres read those reports, respond to them with their candidates, and over time, there are changes in the paper. I'll talk about some of the changes we've seen in 2023 later today. The examiner's report is there for the summer. It essentially has 3 sections to it. There is a general comment section at the front, which talks about the size of the entry, the number of candidates, the grades awarded, the spread of grades and things like that. There's a section A, which is usually relatively short. As I said, it's difficult on section A with the multiple choice questions to really know which questions have been done well and done badly and which ones are lucky guesses and unlucky guesses. But it does allow me to talk about which questions have been done well and which ones have been done less well. So you can pick out the ones that perhaps have been done less well and ensure that candidates are well prepared for them in the future. The questions are ramped, so they do start easy and build their way up to being harder, but in both section A and section B. They aren't exclusively easy, medium, and hard as you work through the paper. So you will find some harder questions earlier on, some easier questions later on. But typically, we do find that the earlier questions are done well, the later questions are done less well, as the level of challenge increases, as you would expect. But then in section B, the biggest part of the report, we do have an individual breakdown of every part of every question. So we tend to have around 30 questions, and each of those questions is often broken down into parts A, B, and sometimes C. And there will be a detailed report there of exactly what the candidates have done. And the examiners will all feed back into this report to their team leaders and then the team leaders to me, so I can pull their comments together and talk about common methods that have been used, common errors that have been made, good ways of working, efficient ways of working, and advice for the future. So that really is the focus of today's session, but also is a really useful resource for you moving forward to be able to have a look at that and then plan your teaching, your response to that effectively. There's the general comment section is here. Again, I'm not going to read this to you. It is publicly available, so you can log on and get this from the Pearson website, but it's typical of the tone and content of it. So it will talk about the summer's paper in this case. There's a very, very similar document for the autumn as well. What we've seen on the paper, as I say, we work incredibly hard to ensure the levels of consistency across all the papers, so there shouldn't be and there won't be huge changes in style or difficulty or anything like that. Obviously, the content of the papers will change over a period of time, but you will see many topics coming up year after year, or at least on a regular basis. It talks about the structure of the paper, as I've just gone through with section A, section B, the multiple choice and the open questions, and then talks about what candidates have done and how they've done it. So, for example, one of the issues we've had over the years is that many candidates left questions that they weren't familiar with completely blank. And I'll talk later a bit more about that, about how we are beginning to see a bit of a change on that. And equally, with it being a calculator paper, we very, very often saw on 2, 3, and 4 mark questions, the calculation appears to have been done on a calculator and the answer written on the paper, but nothing else. And that often will limit the number of marks available because the M marks can't be awarded. The second part of that is then going into a bit more detail in terms of the parts of the paper. So we have number questions, algebra questions, geometry questions, and statistics questions. Talks about the strengths and weaknesses there. Typically and historically, we've seen great strength with algebraic skills and to a greater extent number skills coming through as well. Geometry and statistics historically have been done less well. That is still evident, perhaps a little less so than it has been in previous years. But certainly on this spec, some of the question topics are less important. The question styles are more important. So the problem solving questions are proving more challenging regardless of the content of them. And the algebraic skills do seem to be less of an obvious strength. They were always a very clear strength, but that is changing over time. So The examiner reports will keep you up to date with changes in the whole cohort across the world. There is some general advice in there for centres and for candidates, really aimed at staff in centres, so teachers rather than the candidates, but candidates obviously can have access to this if they need to. And it does talk about how best to tackle the papers. As I said, we'll have a section later on where I give a bit of advice on things like that. And then talking about working out accuracy, rounding and things like that, which are common issues across a number of questions and a number of papers. Again, you'll see comments like that being repeated year on year. And I'm not afraid to keep saying the same thing, because actually until it stops being an issue, I will keep saying it. I'm very conscious that we are recruiting more and more centres to this specification on a regular basis, and people may be reading these reports for the first time. So if you are one of those people who is a regular reader, so to speak, you will find that I do sound like a broken record, apologies, and there will be things on there that you'll see year after year after year. Some people are reading that for the first time and they still need to hear those messages whilst it's still an issue. Once it obviously isn't an issue, I'll probably comment to say it's no longer an issue, and then you'll stop reading about it. Section A report is brief. It is probably a little bit small on your screen, so apologies for that, but again, is available on the Pearson website. It talks about the structure of that. There are 15 multiple choice questions. We are trying, and you will notice over the coming series the next couple of years, to allow a little bit more space around there. They're very often quite compact sections, only taking up 3 or 4 pages for the 15 questions. There will be a little bit more space available. There are obviously certain questions that lend itself to a multiple choice format and others that don't. So you will tend to see typically the same topics coming up in that section quite regularly. So if you do look through past papers, you will be able to work out which questions do come up often and which topics are assessed in that section often. And obviously there is some level of skill and technique in tackling a multiple choice question. We do try to ensure that all of our answers are possible. We don't try and allow candidates to work out which one's too small, which one's too big, and then take a guess out of the other two. We try to make it, as I showed you earlier, that each one is a valid misconception. So we're not just making up random possible numbers. We're giving answers that would be achieved if you did it in slightly the wrong way, if you had a misconception. So hopefully, and we do see there is a good spread of incorrect answers across papers. It's not that everyone gets one right and gets one wrong. It's that there's a good spread across them. People are falling into the traps that we're setting for them. Essentially, we're not trying to catch people out, but we do need to assess those misconceptions and allow you to find those misconceptions so they can be addressed before they move on. There will be a section here where it talks about the questions which have been done well and less well. As I said earlier, there will very often be the early questions are done well, the later questions are done less well, but I will highlight any questions in there that buck that trend, where candidates are doing very well towards the end of the paper on more difficult questions. As I mentioned earlier, very often the algebra ones are done well. And equally, any questions early on that are not done as well, because what we perceive to be easy questions are only easy if the kids have done them. If they haven't studied it, if they've not remembered it, if they've not spent time in it, they can often be more challenging than we anticipated. So then into the actual papers, I've gone through, picked about a half a dozen from across both papers, the summer and the autumn. As I said earlier, it really doesn't matter which one or if potentially both of these you do, in that the advice and guidance will be relevant to all of you. So if you only have candidates sitting in the summer, or you only have candidates sitting in the autumn, so June and October, all of this advice and feedback should be relevant to you. So you don't need to switch off if it's a series that you don't use at present, because the feedback from June is just as relevant as the feedback from October, because there aren't topics or questions that appear in one and not the other, that all the questions and topics could appear in either or both moving forward. So I will reference where these questions have come from, but actually where they've come from is not that relevant really. It's more about the topics. And I've made sure that I've picked out topics in particular that have been done well this year and are typically done well. So they're generally strong performing questions, and then also picked out questions that have been done less well, and either that's a new development for us, they're usually done well and this has changed, so perhaps we've taken our eye off that ball, or they're questions that are generally done badly and perhaps our areas for improvement as referred to in the examiner report. So the first one, excuse me, the first one is from the June series, a relatively straightforward numerical question. So it's question number 19A, so that's quite early on in the section B. Section B starts at question 16. So what is 43% of 278? This is a question that hasn't always been done well, and often has been done without a calculator, with candidates finding 10%, doubling it to find 20%, then finding 1%, then trebling it to find 3%, and adding it all together and sometimes getting themselves into a bit of a jumble. This hasn't been the case in the most recent series. So in the summer, The marks were available for a method, something usually like 43 divided by 100 times 278, or if they work with decimals, 0.43 times 278. Either of those, and it does say OE there, so OE is or equivalent, so an equivalent calculation. It might be that they've done 43 times 278 divided by 100, for example. But any of those would have given them the method mark. If they then execute that method effectively, they get their answer mark. All the way through the paper, unless it's stated otherwise, a correct answer scores full marks unless otherwise stated. So if they just put a correct answer on the answer line, we would award 2 marks because the correct answer implies a correct method. However, we do strongly encourage candidates to show working out, and particularly with the calculator paper, we encourage them to do the calculation, write the calculation down that they're going to do, then do it on the calculator, then write the answer down, and then type it in again and double check the calculation, because it's very easy under exam situation to press a wrong button or misread a calculator screen or anything else, and the working marks will very often secure them a mark that they would have lost otherwise. Equally, if they put their answer in the wrong format or round it badly or something like that, which we'll talk about later, that can often lose them a mark as well. But in this case, as it says on the report, you can see the clip there from the report, part A was answered correctly by the vast majority of candidates. Common errors that were seen, whilst few and far between, were misplaced decimal places, where somebody's perhaps times by 43 or 4.3 or 430. And very occasionally the candidates have got the numbers the wrong way around. So instead of 43 divided by 100, they've done 100 divided by 43. But that is a real strength, and that is a question that candidates typically are getting correct. So if your candidates are not getting that one correct, that probably is something to work on. If they are, then probably just want to keep plugging away and know that they can be pretty confident with those questions. That, again, they do come up quite often in various formats. Second one through, again, is a common question, decomposing a number into a product of its prime factors. So in this case, 240 is a product of its primes. The working space was far bigger than is shown on the screen there. I've put the answer line at the bottom, but there was a lot more working space to show. There were a range of different answers and methods, actually. The one that's shown is an example. So we have that kind of tree diagram type of thing. There's also the tabular form of doing it. Many candidates can just write the answers down. It's a relatively straightforward number. As it says at the bottom right-hand corner, we will accept the answer using index notation, so 2 to the power 4 times 3 times 5. We will also accept dot notation for multiplication, which I know is common in some areas of the world. And the method is for a correct method of decomposing their number. But in case, and there are odd occasions where somebody clearly doesn't know their times tables, we will only permit one arithmetic error. So if they were to decompose 240 into being, instead of 8 times 30, they put 9 times 30, we would condone that for a method mark and keep going. But if they then split 30 into 7 times 5, they would then lose that method mark because their method is flawed, as there are repeated arithmetic errors. The good news, again, is that there weren't any, there weren't very many at all. It is a common question type, as it says in the report there. The candidates who are familiar with this did it very well, very efficiently, very effectively. There was lots of consistency on this paper, lots of different methods, but those methods are being repeated. Probably the most common error, whilst it wasn't overly prevalent, was that there's a multiply by 1 at the end of it, either in the diagram and or on the answer. Sadly, that does lose them a mark because it isn't correct. 1 is not a prime number, although many mathematicians think it should be, and the correct answer should not include a times 1 in there, so it shouldn't have 1 times anything else. If that is there, it does lose them a mark. There are other candidates who obviously don't understand fully what to do. They understand the word prime, they understand the word factor, so they are perhaps decomposing into factors. So we're getting a list of factors of 240, 1 times 240, 2 times 120, and so on. And then they're going through and picking out the ones that are prime. So it's along the right lines, but not quite doing the right thing. But the question style, the question format is very common, very consistent across a number of specs, and certainly on this one. And is certainly one where the vast majority of candidates are picking up full marks. So it's certainly one that's worth looking into. Next one, again, it is a bit of a worded problem, and actually it's unusual in that it's a worded problem that's generally done very well. There aren't a huge number of words here. It's not a massive question, and there are sometimes even less words than this, even fewer. But essentially questions where we have an amount and it's being split into a 2 or a 3-part ratio. In this case, it was a 3-part ratio, the ratio being 7 to 8 to 9, and the amount essentially being 504 centimeters, so the combined height of 3 students. The question they're asked does change each year, and some candidates do need to read the question a little more carefully, in that they know what to do with this. They know to add the 7, the 8, and the 9 together, and then they know that whatever they add up to, so in this case it's 24, to divide the total by that 24, But then it's the next step that sometimes trips them up, because in this case, we're only asked for the height of the tallest student. So it's only a 2-mark question. There's one method, add them together, divide by 24, and then multiply it by the 9. So in this case, it's divided times by 9. However, it does mean that there are candidates who put the correct answer, in inverted commas, on the answer line, but alongside other information. So it might be that they would do 7 multiplied by 24, 8 multiplied by 24, and 9 multiplied by 24, and give us a ratio as an answer. We typically have been sympathetic towards that as long as they found the correct answer, but they do need to answer the question that's in front of them, not just robotically and methodically work through splitting something up into a ratio. So sometimes it says work out the tallest, sometimes it might say what's the difference between the tallest and the smallest, other times it might just say, you know, if there's an amount of money shared between 3 people, how much does each one get, or how much more does he get than her, and that type of thing. So please do encourage candidates to read carefully. As it says, most candidates gain full marks on part B of this one. It's question 22 from the summer. And those who didn't, generally, it's for dividing by the 9. So work out the height of the tallest student. In this case, it's the 9 part of the ratio. And those who got it wrong, the most common error was to do 504 divided by 9, which obviously is not the right way to do it. So adding together, dividing by what they add up to, and then finding that as a factor. And then I think the last one we're going to look at as a real area of strength, and it really is a real area of strength, is Pythagoras. Lots of candidates used to confuse Pythagoras and trigonometry questions. Obviously, they're very often taught together and linked together. In this instance, this was done incredibly well. And I think probably is the first time I've been really confident that candidates have got to grips with these questions. There is obviously the possibility of candidates using trigonometry to solve this, to find an angle using the 2 sides, and then to use another round of trigonometry to find the missing side. However, the intention is that if they're given 2 sides and no angles, that they will use Pythagoras. We did used to have real issues with candidates either always adding or always subtracting their 2 sides squared. So in this case, we'd see a lot of 11.2 squared plus 14.6 squared. But I think that has become far less of an issue recently. And certainly when this paper was sat last year, it was done incredibly well. So 3 marks for this, which is common with the IGCSE and other papers as well. The first mark is for using Pythagoras. So a squared plus b squared is c squared in whatever order they want to. So basically squaring the 14.6 and then squaring the 11.2 and squaring the other side. Whether they refer to the other side as x or bc or the unknown or whatever doesn't matter too much. We're not too worried about notation. So you'll see on the mark scheme there are things in brackets that don't have to be seen. They're part of a method, but they don't have to be there to get the marks. Once they've got the numerical answer, in inverted commas, to that stage of the working, in this case, it's 87.72. We will fully accept that if it's in surd form. There's nothing wrong with that. We then ask for an answer to correct the 3 significant figures. Now, it is a common theme throughout the paper that we do ask students to round their answers like this. The reason for that is if you get a big, long answer on your calculator screen and don't know what to round it to, it can cause anxiety, stress, panic, whatever else. So we always tell them or ask them to round it to something. Sometimes it's decimal places, sometimes it's an integer, sometimes it's significant figures. However, we won't be assessing that on every occasion because there are many questions on this paper that are done with a calculator and will lead to long decimal answers. We don't necessarily want them to write those long decimal answers out, although actually it wouldn't be a bad idea to do that. And we do ask them to round, but as long as their rounding is not incorrect, we will award marks even if their answer is not necessarily correct to 3 significant figures. So in this case, we will accept 9.36, we accepted 9.37, and equally we accepted 9.36589 or whatever else combination of it. So I think a good piece of advice, even though candidates are doing this well, is for now in year 9 or whatever you are in your country at the age of sort of 13 or 14, candidates would be encouraged to write out their whole calculator display. It's not a particularly long paper. The majority of candidates don't seem to be pushed for time. So writing out their full calculator display and then rounding afterwards would be a good way of securing that 3rd mark if they are potentially dropping it. However, as I said, it's not a massive issue because we are quite accommodating of that. It is something that as they get older, they will need to tighten up on. They will need to get better at doing that. The mark schemes as they get older do get slightly more strict. But actually, in this case, it's not an urgent issue. It's just something that we encourage for the mathematical accuracy that we all want to see. The marks were very high on this occasion, but there were some rounding errors, and it's mentioned that just to error check their answers. The other thing I have mentioned in the examiner report for this question is just that sense checking, in that they can see and they will know that 14.6 is the longest side. It's visibly the longest side, and we know it's the hypotenuse, so it must be the longest side. But we did get some answers where they've done 11.2, add 14.6, square rooted to get an answer, which obviously n is bigger, and haven't sense checked it, haven't thought, well, actually, that can't be right. So having an answer that's less than 14.6 is obviously essential. So if they do catch a wrong button on the calculator, that would help them to iron out any little issues, or if they've got a misconception, it would help them to pick those up. And there are times where students do perfect working out, perfect method, and then just get the wrong answer at the end, and it's obviously just pushing the wrong button. And it's a real shame to see them dropping those marks. So they are few and far between, but we'd like to get rid of those completely if possible. And then the last one, I've included this for the first time because actually we have on this spec introduced construction questions, and they have typically been done relatively badly. This one wasn't done quite as well as the other questions I've mentioned previously, but, and again, I've squeezed it in a little bit, so you're not seeing the full question. It was a full page question. But for the first time, there were a large number of candidates who did this very well. The examiner report, you can see there on the right, does acknowledge there are still several candidates who clearly had no understanding of this problem. They just haven't tackled it before and didn't know what to do. So they left it blank, or they coloured it in, or they worked out some angles, or all sorts of other nonsense. However, those who knew what to do did it very, very well. It was only about 50% success rate, but those who did it brilliantly. So I did want to flag it up because that's a big improvement. I do think it's still an area of focus. You will know your candidates, your centres, you know what you're teaching and what you're not. But going back to what we said earlier about equipment on the paper, it does say about having a ruler and a pair of compasses, and they are necessary for these questions, which do come up relatively frequently. Sometimes it's a bisector of an angle, sometimes it's a bisector of a length, sometimes it's a length like this one within a triangle. There's a variety of different questions. Sometimes it's constructing a triangle or a quadrilateral. There's lots of different things. But those construction questions are relatively straightforward, and those who can do them very, very well. It's unusual to see candidates scoring 1 mark on this or doing an answer that's nearly correct. They either just don't get it, they don't know what to do, or occasionally leave it blank, or as in this case, they do it very well. So it is a question that candidates who are taught how to do it typically seem to do it very well. So maybe one that's worth pushing a little bit more. In terms of questions that are not going quite so well, this one, the first one, is one that stuck out like a sore thumb. The maths involved in this is relatively straightforward, but there are a number of mitigating factors that may lead to candidates having done this one badly. And we were all quite surprised that the marks were as low as they were for this question, essentially. It's only question 18, it's from the summer paper, and it's therefore the third question into section B, so relatively low level. There are lots of words there, and I am conscious that's a little bit overfacing, particularly if a candidate's got English as an additional language. But even for 13 and 14-year-olds who've got English as a first language, there is a lot of reading to go on here. But the structure of the question is something we try and use consistently, in that we've got things broken down into bullet points. We have parts of the question sectioned off so they can work through it. And the key to this really is working through it step by step, methodically. I'd always encourage candidates to read the full question first, put the pen down, read it all, then pick the pen up and work through it step by step by step. Don't try and tackle it as one big question, which I think many have tried to do, is try to just find the answer. And actually in this question, the answer comes from lots of little answers on the way to it. So actually doing those small incremental steps is a real strategy that needs to be introduced. And I wanted to put this one first because I think it's one of the most important ones to go through. And it is something you will see more and more over our coming papers, that this style of problem solving is going to be necessary moving forward. So we have introduced it on this spec, and it has been consistent since 2019. So we've got Ankit, Marcella and Rasheen. They've each bought a plant. The plants were 9.7, 7.5 and 83 millimeters. So obviously you've got an instant inconsistency there in terms of decimals, fractions and different units. So it is a little confusing, but reading the question carefully, thinking about what they've got, these are all measurements that are probably fairly familiar. You can see them on their rulers if they've got a ruler in front of them. So 9.7, 7.5 and 83 millimeters are not particularly difficult, but we did have lots of candidates misreading or not looking carefully enough and thinking it was 83 centimeters. So again, sense checking, that's unusual to have two plants at a 9 point something and 7 point something, another one that's 83. It then says in the second section of the question, after 1 year, each of the people made a comment saying what had happened to their plant. And at that stage, having read it through once, I'd encourage candidates to do the working step by step. So Ankit said his plant's new height is double its original height plus 12.8. So with a calculator, times by 2 plus 12.8 is not difficult to do. So I would literally encourage candidates to be doing 9.7 times 2 plus 12.8 and write it down there. And then whether they do it in the working space, which obviously on the actual paper was far bigger, or whether they do it next to the question stem, doesn't matter. We'll look all over the paper to mark this. And that's getting them on the way to their first mark, as you can see from the mark scheme down the bottom there. They then need to do the same for the second one. So 7.5, they can type fractions into calculators. They could just put 7.5 instead. But again, it's their original height squared and then subtract 23.5. Squared did trip a couple of candidates up, and actually some have doubled rather than squaring. So just clarify what squared means. But again, on a calculator, the calculation is fairly straightforward. And the last one, my plant's new height is half its original height multiplied by 7.8. Again, the numbers are not pretty, but it doesn't matter with a calculator. So doing the sum carefully, doing it twice to check it's correct should give them the right answer. So we've got 83 millimeters halved and then multiplied by 7.8 to get an answer in millimeters, or they switch straight away to 8.3 centimeters, excuse me, and then they do the calculation after it. Having done that, it then says what's the height difference between the tallest and the shortest. Now, some candidates just didn't access that part of the question. It is a question where it says they must show they're working out. So just a correct answer is not what we're looking for, and it does need units with it. Again, there's a choice of answer there, either 0.55 centimeters or 5.5 millimeters is the difference between the two. The answer does need to be in correct units, and the third method mark is dependent on the first two. So going through those first 3 steps is important. If they make an error in their calculations, they can still get all 3 method marks. They don't have to have accurate answers, but the answers are written down on the left-hand side there. So 32.2, 32.75, and 32.37. Again, relatively straightforward terminating decimal numbers. So I didn't anticipate this being as challenging as it was, but that structure seems to have caught some candidates out. So the comment there from the examiner report, sorry, is the most common error is about not converting the 83. So just reading carefully, looking at units carefully, especially when one number's a different size, a different magnitude to the others. Knowing what the word squared means and not doubling. I think one or two cases we saw was actually square rooted as well. However, most candidates that calculated the heights correctly then went on to score full marks. So those candidates who did do those first 3 incremental steps then seem to have gone on and been really successful on this question. So it was a real divide. Those who did it well, but actually lots of them didn't really get into the nuts and bolts of the question, sadly. And it is a question style. I'm not trying to give away what's coming up in the future, but there is a question style that we are committed to, and it will help to develop the students' understanding. It's that way of working that we need to see implemented on these questions. The next one is less structured, and actually the structure of this, the feedback you'll see from this is that actually the candidates needed to introduce a structure to this essentially. So many candidates are trying to solve this problem in one sum, and that's really not the way to do this. So you've got the cylinder, radius of 3.5, height of 4.8, and to work out the surface area, essentially it's a 3-part question. So there's the circle on the top, the circle on the bottom, and the rectangle that's bent around the outside of it. Again, they're asked for 1 decimal place, but we've not insisted on that decimal place. So anything between 182.4 and 182.6 is acceptable. Again, answers in terms of pi have been accepted if they're accurate. Certainly working out using pi is accurate as well, but we do encourage them to work in decimal places. The problem with this is I think many tried to work out the volume instead. And those who were trying to find a surface area were trying to do it with one massive calculation rather than breaking it down. So again, the strategy, whilst it's a less structured question than the last one, the strategy needs to be the structure. So it's not necessarily about being able to do the maths, it's about being able to attempt the question. Again, it's not a big worded question, it's not particularly a problem solving question, it's a relatively straightforward problem. Slightly higher level, it is a little bit further on in the paper, it's question 21. But basically thinking about what you are doing. So what is the surface area? Well, it's the circle on the top, it's the circle on the bottom, it's the rectangle around the outside. Finding the dimensions of each of those, knowing that the top circle and the bottom circle are the same makes life easier, and then being able to work with the area of the circle and the area of that rectangle, which obviously comes from the circumference of the circle and the height of the cylinder. So one to flag up there, well worth doing in practice if you're going to cover this as a practice paper or as a mock exam, whatever else. And again, I would stress as well as the method to find the areas. I know that's a relatively challenging skill, but actually the strategy around the question is crucial. The next one is precisely the opposite. You'll notice these are both question 21. So that's question 21 for the summer there. Question 21 for the autumn series was quite the opposite. Not very wordy at all, not very problem solving, and doesn't really require very much structure or working out at all. and strangely enough, the reason I've included this is it's always been done very well in the past. The working out for this is virtually non-existent. So essentially, the candidates need to spot that the numbers go up in tens, so therefore it's 10n, and they get the first mark for writing 10n. And then to get from 10 to the first number in the sequence, which is 7, we take away 3. I know there are other ways of doing it. They're all absolutely fine. We're very accommodating of other methods, of other ways of expressing their answer. But essentially, any answer which is equivalent to 10n minus 3 is absolutely fine. And any method that they use to get there is absolutely fine as well. But we have found, unusually, that only about 25% of candidates got this question correct. Again, many who got it correct many who picked up marks got it completely correct. Those candidates who did get 1 mark, it was typically for getting 10n. They realized it went up in tens. But we also saw a whole range of reasonably common wrong answers, some 7n's because they saw the 7 at the start. They knew there needed to be an n in there. Some of them were put in plus 10 or plus 10n and things like that. But a surprisingly large number who I just wonder if, because the candidates have been so good at this previously, it's gone off the boil a little bit. We've overlooked it, and actually perhaps just needs to be added back in, because it is a pretty simple skill. It's a pretty common question, and it's relatively straightforward, unlike the last two, which are a bit more in detail and involved. This one is pretty straightforward. The next one, again, is a common question, and again has been done generally quite well. It is a little bit more difficult this year, in that we've got 5 groups to find the estimate of mean from. And also we've got different size groups this time, so 0 to 6, 7 to 12, and then 13 to 15 obviously is a smaller group. But essentially, the method of finding the midpoint, we've given them the blank column on the right hand side as a bit of a hint, bit of a reminder that they need to find a value for x, the midpoint essentially of each group, and then multiply it by the frequency to get those numbers. The numbers are not particularly accessible, pretty numbers, but with a calculator, they're fairly straightforward. There's no long, hideous decimals. They're all relatively straightforward. And again, as I said, this has been done very, very well over a number of years and seems to have slipped in the most recent series. So again, I just wonder if it's been taken out the firing line because it's always been done well and perhaps aren't spending as much time on it and perhaps need to just go back to focusing on this one. The second mark is available for adding their right-hand column together and adding their middle columns together. The most common area there was dividing by 5 because there's 5 groups to try and find the mean. That isn't going to work, obviously. There were a few candidates misinterpreting the word estimate. So estimate of mean is an indication of a specific methodology. It's not saying make an estimate as in take a guess, which some of them did. And again, it's a 3-mark question, so there's quite a lot involved in this. There's quite a lot of work to go through. Some candidates just writing an answer down. Now, if it was a correct answer, that was absolutely fine, but we did see some answers of 14 or 15, which actually might have been done correctly on a calculator and then just rounded badly or severely, but they didn't get marks and couldn't get marks for doing that because it's not a correct answer. And actually looking at the table, they could have just picked 14 as being the middle number in the middle group, and that's not what we wanted from them. So they do need to show working out. It does say show your working. A correct answer, 14.65, would have got full marks because that's the only way they could have got that number without any working out. However, if they put something else, if they put 14.6, 14.7, 14, 15, which we did see all of, they wouldn't have been given full marks without the working out to support it. So working out is essential on this. Again, I've squeezed the question in for the slide, but there is far more working space to use there. And with a calculator, it's a relatively straightforward question and a consistent method. They need to look at the midpoint of the groups, whether there's 3, 4, 5 groups. They need to multiply by the frequencies, and then they add the right-hand column, add the middle column, and do a division. Occasionally, that division is done the wrong way around. But again, sense checking their answer, their estimate of mean should be around the middle of that. If you do your division the wrong way around, if you're doing 20 divided by 293, you're going to get an incredibly small decimal number that obviously isn't the average for that. So a bit of sense checking, thinking about what the answer is and where it should be, what we're expecting to get, would help them to identify any issues like that. And again, another question which typically and traditionally has been done very well, as I mentioned earlier, algebra is always done very well on this paper, and that does seem to have slipped a little bit. It's not a massive concern. The algebra skills are still very strong, certainly a lot stronger than I see in centres in this country at 13 or 14. But compared to previous papers and previous series, this question in particular and some of the algebra skills across the board, and actually not just the skills, but the kind of algebraic accuracy, the correct notation, the correct format, the correct way of writing things out, use of brackets, things like that, hasn't quite been as good as it has previously. So I don't know if that's something that's been allowed to slip or whether it's an area that we've not focused on. I have encouraged for a number of years a greater focus on geometry and statistics and less on algebra, perhaps. And maybe it's taking our eyes off the ball with one has allowed something to slip. But again, I've squeezed the working space on here. There was plenty of space to do the working out for this question. The numbers are relatively straightforward. I suppose the add and the subtract causes one or two issues for one or two candidates, but generally speaking, 2 marks for this is often usually secured. But in many cases last year, 25B, there were a far smaller proportion, as it says in my report there, a surprisingly small number of candidates, less than half, actually got this question correct. They should be getting 4 terms, so they should be showing their 4 terms. Showing the working out is important, particularly when it's positive and negative, and they might get the negative number wrong. So they should have y squared plus 3y minus 6y and minus 18. If they've got all 4 terms correct, but they've messed their signs up, they'll get a mark. If they've got 3 of the 4 terms correct with the correct sign, they'll get a mark. So we allow 1 error, essentially. And then for the full 2 marks, they then need to simplify the middle section. So minus 6 add 3y, or 3y minus 6y is the minus 3 in the middle. They need to simplify. We did see some oversimplification. There were some where y squared minus 3y is 2y squared or something like that, which obviously, even with the correct answer, if they then carry on going, they lose that mark afterwards because they've given the incorrect final answer, even if we've seen the final answer on the way to it. There were a few unusually who've left their answer unsimplified. So y squared minus 6y plus 3y minus 18. I know you can't see it on the paper, but it does say fully simplify, so expand and simplify in this case. So they need to simplify as well. And again, the numbers are not hard. There's no need for a calculator. I can't imagine too many needing to do 3 times 6 on a calculator, even with a negative. And it is something that's been done very well previously. So we know that 13, 14-year-olds in our centres can do this. Perhaps just need a few reminders and a bit of a focus on this question where if and when they do it as a past paper or a practice paper moving forward. So hopefully that's given you a flavour of some of the key topics, many there that either are traditionally challenging or particularly have been less effective in recent years than they have been previous to that. So I think the new style of paper has presented new challenges over the last few years. Obviously, a bit of a disruption with the pandemic. Whilst the papers are available for 2020-21, the global pandemic obviously has had a slight impact on, or great impact on centres to different levels across the world. And we have seen some changes in patterns more recently, which is why it's good to be able to do this session today and point those out, and hopefully you can learn from them. In terms of potential improvements, I've based these on 2023 and 24, but these are really looking forward. We can't go back in time and change anything now, but looking at 2023 June and October and moving into 2024 and beyond, the tips I would suggest for everybody, and these are generally not mathematical, these are generally organizational in terms of the way that the students and candidates are attempting the paper. So if you can give your students anything, any hints and tips as you are preparing for these exams in the future, you know, the day before, the week before, or each day you're teaching them, just to reiterate these things that you want to see in their books, things that you want to see on their practice papers, on their mock exams, and things that you need to drill. They're not necessarily things that we're awarding marks for, but they are things that if they had been done, the candidates would have secured more marks, which is what we all want essentially. So being fully equipped, I've mentioned every year, obviously the vast majority of candidates have a calculator with them, but actually being fully equipped and using the equipment you've got in front of you, because there are always occasions, frustratingly, where they do brilliant work and then get the arithmetic wrong. Even the simplest of sums, even that 6 times 3 or 6 times minus 3 on that last question, just check it on a calculator at the end when you've got a few minutes. Just do every calculation on your calculator, make good use of it. Even if you know it, double check and iron out any little issues that you might have made under pressure in an exam. That particularly is referring, as I said earlier, to the rulers and compasses, which I'm imagining some candidates may have had the equipment and didn't know how to use it, but I'm also imagining it's not the most common of everyday usage things. So having those available for candidates, making sure they're bringing them in for their exams is important. Attempting every question has improved over time, but there is still some room for improvement, particularly towards the end of the paper. There does seem to be some signs of 1 or 2 candidates giving up. It might be running out of time, but there's no real indication of that, if I'm honest. But certainly some of the worded question candidates seem to be just turning over the page and moving on, rather than doing what I can do. Looking at a question thinking, oh, I can't do that. Well, actually think about what can you do then. If you can't do all of it, that's fine, but have a go, particularly on the 3 and the 4 mark questions, the bigger ones, which are a little bit more daunting, and probably the ones that they want to shy away from tackling sometimes, but they are the ones where it's most important that even if you can't get 4 out of 4, they don't get none out of 4. They get 1 or they get 2. So there's some brilliant mathematicians out there answering great questions, but then dropping 4 marks on something that actually is far less mathematically challenging. So attempting every question is really important. It is a relative strength for this spec, but actually we do need to try and push that even further. Showing working out, as I've mentioned all the way through this morning, is absolutely crucial. Even in section A, there will be, as I've mentioned, slightly more space available in the coming series for section A to have working out. It's not going to secure any more marks in terms of their answer or the way that we mark them, but there are lots of questions, particularly the algebra questions in section A, where the students seem to feel that they need to do all the working out in their heads, and that's inevitably leading to some slips, and some of those slips are anticipated and it leads into one of the incorrect answers. So showing the working out just like they would do in section B will help them to get the correct answer. In terms of marking it, it makes no difference to us whatsoever. Whether they've got A, B, C, or D is the only thing we're interested in, but them getting the right answer will be helped significantly by showing their working. Reading questions carefully, I've mentioned there are questions where they're asked to do something specific and they just don't do it. There are questions where it says, what's the tallest height? And they give all 3 heights. There are questions where it says, how much money has he got left? And they give the amount of money that's been spent. There are questions where it says, does Joan have enough money? And the answer is 263, which doesn't make any sense. So just reading it and going back and rereading, what is the question? Have I answered that question? It's very often the working is perfect, but they're only getting 2 out of 3 or 3 out of 4 because they've not then answered the final question. If the question is what's the difference between these two, or have they got enough, or is this true or false, and that type of thing. Ensuring that answers make sense. Again, I've mentioned a number of times this morning that sense checking their answers. Does it seem sensible that the mean is less than any of the other numbers in the table? Does it seem sensible that the shortest side of the triangle is actually bigger than the other 2 sides? Does it seem sensible that somebody who's earning $10 an hour is going to earn £6.3 million in a year? Having the sense check on those numbers to not just push buttons on the calculator, but think about what their number is and what it represents, that will help significantly. Avoiding overly severe rounding is probably the biggest issue at present. It's very, very common. I understand why. I understand there are conventions in different areas of the world, different tiers of mathematics and different traditions. I've been exposed to many of them as a student, as a teacher, as an examiner. And we all work in our own different ways. Some places encourage 2 decimal places. Some will say 1 significant figure. Some will say 2 significant figures. Some will say use whole numbers. There's a whole range of things. But actually, what candidates need to do at this level is read the question. As I encouraged earlier, write the full calculator display as an insurance policy, essentially, to make sure that you've got your full answer down there accurately, and then round it as you need to. And if they can't round it, it doesn't matter. There will be some questions where it specifies round this number, and they will get a mark for doing that. But the vast majority of times they're asked to round their answer, it's for their convenience and for their reassurance rather than to award marks for it. So if they're encouraged to round to 3 decimal places or 3 significant figures, it's just so they know how to express their answer. If they don't do that accurately, they typically don't lose a mark. But overly severe rounding is very, very common. So even if you are training your candidates to round to 1 decimal place, 1 significant figure, an integer, or whatever else, please get them to write the full calculator display first, and we will mark that, even if the rounding then goes wrong. I mentioned earlier about breaking down and the focus on worded questions, going through line by line, literally putting the ruler on the paper, reading the whole question first, and then going through line by line. At the end of line 1, what do I know? What can I do? Do a sum straight away. At the end of line 2, what do I know? What can I do? Highlighting, circling, underlining, key values, key figures. The words typically are not that important. Whilst they need to read them carefully, what we need to do is pick out the values. But I think there is some glossing over of the words rather than interpreting them and highlighting the bits that are most important. But that the structure of those worded problems and the problem-solving nature of those worded problems does seem to be a challenge, regardless of whether it's number, algebra, shape, or geometry, I should say, or statistics. Within that, geometry and statistics remain the lowest performing areas. However, they are improved. And as I said earlier, the last bullet point is that algebra has been typically by far the strongest and is still the strongest, but has dropped a little bit. So it does look like people are taking on board the advice and guidance and the response from their candidates and saying that geometry and statistics are a weakness, so let's focus on them. Algebra is a strength, so maybe let's focus on that less, but they are kind of converging towards the middle. So please do be aware the algebra marks have slipped slightly. I've focused on that earlier. Geometry and statistics do remain an area of focus, but they are improving, so there is headway being made on that front. I hope that's been useful.